So I said we'll go through the normal distribution part. Okay. The normal distribution part is also interesting, so look at this. So the frequency distribution in the table below represents the results a random sample of size 40 from a population with mean, all right, 12 and then standard deviation 4, using a significance level of 0.025. Determine whether the frequency distribution is normally distributed. Okay, so what happened is that there was some random experiment, okay, and then the population of size 40. Okay, so here our n is 40. Our n is equal to 40. All right, our n is equal to 40. Now this is our mu, and this is our standard deviation, right? So it says these are frequencies. All the time you have to see this. So when you find out whether the data here can be modeled by what? A normal distribution. Can the data be modeled by a normal distribution? That is what we want to find out. Okay, so these are the experiment, the random experiment, and then the frequencies. So less than 6.5, the frequency was a 3. Between 6.5 and 9.5, the frequency was that. This was that, and this was that, and this was that. All right. So remember, in any test, the first thing you have to state is the hypothesis. So the data, the given frequency distribution is what? Normally distributed. So the data there is normally against the given frequency distribution is not normally distributed. Okay, so you were asked to test whether the frequency distribution is normally, so your null hypothesis will look like it is normally distributed against it is not normally distributed. Okay, all right, so now you have to calculate. Now we have our FIs. These are the FIs, so we don't have any problem with the FIs. Now what we need is our EIs. Okay, expected. So these are the frequencies you are observing. So what will be the frequencies if this is happening as normal? All right, remember you need n times p, isn't it? So our n is 40 already, so what we need is our p. Okay, and we calculate the p using the normal distribution. Okay, and remember that if x follows normal distribution, then we will need the mu. These are the parameters, and then the variance. Okay, so these are the parameters in the normal distribution, but fortunately for us, those parameters are given. This is the mean, and then the standard deviation. So taking a square of this will give you the variance. Okay, square of this will give you so it is already given, so it means you won't estimate any parameter. So in that case, your c is automatically 0. This is a c in the degrees of freedom. Okay, because the distribution, which is normal, the two parameters are given in the question, so you won't have to estimate anything. So that one is 0 already. Okay, all right. So stating the hypothesis, you are okay. Now you have to calculate the probabilities, and then this is not mu, you know, this is not standard normal. Okay, this is not standard normal. This is not standard normal distribution, so you have to standardize it. Remember that the standard normal distribution, we say that if x follows the standard normal distribution, then you have a mean of 0 and then a variance of what? 1. Okay, this is what we say it's a standard normal. So it is this that we have the probabilities. Okay, so if you, it is this that you have the probabilities. So the fact that this is mu is 12 and then standard deviation is 4, that means variance is 16. It means it's not standard, so you have to standardize it by using this standardized approach. Okay, all right. So instead of writing calculating any probability, instead of saying probability that let's say x is less than or equal to small x, all right, you won't say that. You rather be saying that probability that z, okay, is less than or equal to, okay, x minus mu all over sigma. Okay, so what you have to do is that now that you are going to do the thing, if you have this probability, then you are going to transform it to this. Okay, so that x value will be here minus the mu for this, which is 12, over the standard deviation, which is 4, and you can read this on the standard normal table. Okay, so that is what we have done here. So here he did a standardization. Okay, he did a standardization. So if he didn't do a lot of stuff, but so we are looking at probability that this is probability that x is less than, it's probability that x is less than 6.5. okay, so that's what you have. That means you transform this to probability that z is less than 6.5, right, minus 12 all over 4. okay, all over 4. So this is what has been given here. So 6.5 minus 2 over 4, when you do that, you get this value, and then you go and look on the table, okay, for phi of negative 1.38, and that's the value. Okay, all right. So you go through this, and then you work things out. When you are done, you will get this as your, when you get all the probabilities, remember you have to find your expected frequencies by multiplying 40 by all the PIs, and then you remember the rule of 5. okay, so this is less than 5, so you add it to this to get 10.573. this also less than 5, add it to this. So now you can see that your expected frequencies has now reduced to 1, 2, 3, 4. That means you have to do the same thing to this part. So I have 1, 2, 3, 4. Okay, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so when you add the whole of this, you get a 40. So this is your chi-squared. This is your chi-squared. This is your chi-squared value, and then now your k is now 4. okay, so you can find your degrees of freedom. Okay, is now 4. And find your degrees of freedom, and then yeah, when you sum everything, you get that. You sum everything, so your chi-square is rather this. When you sum everything, you get 2.3108. Degrees of freedom is 9 points. That when you compare, this is far less than that, so you fail to reject and conclude that it can be modeled by the normal distribution. Okay, all right. So these are exercises you can try your hands on, and then you can send your solutions to us so that we can go through and see whether you are on the right path. Okay, so enjoy your day.